Let's talk a bit about how DHCP behaves with the fabric. We are going to notice that um, if we relay DHCP requests to the DHCP server, as we usually do with traditional networks, we are going to face an issue. So let's examine what will happen if we plugged in a device using regular DHCP relaying messages. Uh, this device wants to acquire an IP address, so it will send a DHCP request into the network. Remember that this request is a broadcast. Then the edge node will intercept this message, because remember that edge nodes are running DHCP snooping, and it will encapsulate this request into a VXLAN tunnel in order to relay this request to the DHCP server in a form of unicast. So this VXLAN packet will eventually arrive into the border node. Then the border node is going to encapsulate this relayed request, and it is going to forward it to the DHCP server. Then the DHCP server is going to assign an IP address. It will notice that this request was relayed by the default gateway that uses the IP address 10.1.1.1, and then it will assign an IP address, and it will send a reply message including this IP address that it wants to assign to the device. And the destination IP address for this reply message will be the IP address that corresponds to the default gateway. But an issue arrives here, because the border node must encapsulate this reply into a VXLAN tunnel, and it must send that information to 10.1.1.1. But remember that in the fabric we are using Anycast gateways, and several edge nodes share the same IP address. So the question arises here exactly to where the border node is going to send this encapsulated packet to. Exactly to what edge node. The only information that the border node has is this IP address, but this IP address is an Anycast IP address. Several devices have this IP address. So the solution for this issue is using the RFC 3046, which is the relay agent option 82. So let's see how the option 82 will help us solve this issue. Well, let's see. Let's plug a device here into the network. Then this device is going to send a DHCP request into the network. Remember that this is a broadcast. Then the edge node, given it is configured to use DHCP snooping, is going to intercept this request, and it is going to relay it to the DHCP server. And it is going to encapsulate this relayed request within a VXLAN tunnel, but it is going to add option 82. And when using option 82, the edge node will include inside option 82 the loopback that uniquely identifies this edge node, which is an R-lock. So it will use the IP address 10.0.0.1, which is this IP address. Then the border node will receive this relayed request, and it will send this request to the DHCP server. The DHCP server is going to assign an IP address because it noticed this IP address that it is relaying this message, and it is going to send a reply. But given this DHCP server is compliant with option 82, it is going to send a reply message destined to the default gateway IP address, but it is going to also reflect option 82. And remember that within the option 82, we have inside of that option the original RLOC IP address that corresponds to the H node that originally relayed this request. So the border node will receive this reply from the DHCP server, and it is going to intercept that message, and it is going to read what is inside option 82. By doing so, the border node will have enough information to build a VXLAN tunnel for the reply. So it will send this reply to this IP address that is inside option 82. It will not use the original destination IP address. So it will send this VXLAN packet to destination IP address 10.0.0.1, which is the IP address of this edge node. So this edge node will receive this reply. It will de-encapsulate it, and it will send it to the device, so the device will acquire an IP address. That's it.